Hi, it's me again, Cadet Bingel, and in this video we're going to plot the Navigation 213 Eplan 1D, this one. And the things we need to use is compass divider, eraser, a pencil, and the two triangle rulers, and most especially, last but not the least, is our navigational chart number 9. So, keep watching this video. Now, before proceeding to the plotting of the Navigational 213 Eplan 1D, we need to understand first the scenario description. At 13:30 the vessel is at the vicinity of the west part of the Panay Island, on course of 200 degrees true by 10 knots with a falling tide with tidal stream speed of 0.6 knot. The OOW observed Pusho Lighthouse. It bears about 330 degrees relative with a distance of 6 nautical mile. Plot the ship estimated position or EP at after a half an hour or 1400s. So now, in order for us to locate the ship's position, the thing we need to do is to find the push point of lighthouse. Then it says in the scenario description is that it has a relative bearing of 330 degrees. So here's my tip for giving a true bearing from this relative bearing. So the ship's position, like for example this one, so 200 degree. So this will be the ship, that one. In order for us to get the true bearing of the push point of lighthouse, which was at 330 degrees relative, this will be our true bearing of the ship. So we need to relative plus a true bearing is equals to true bearing of that object. So relative is equals to 330 degrees plus the true bearing of the ship is equals to 200 degrees. Then 300 plus 200 is equals to 530. Since getting the true bearing, we cannot exceed to 360. 360 is in the total of the compass. So minus 360 degree, then we got 170 degrees. So that will be our true bearing. The true bearing of the Pushu lighthouse from the ship is equals to 170 degrees true. Since we got the true bearing of the Pushu Point lighthouse, now we need to locate. So again, it's about 170. Here's our 170 degrees true bearing. Then the Pushu lighthouse is right here. So we need to drag our ruler, triangle ruler, then make a line of position right here. So just as long as it's all clear with this line of position, the Pushu Point lighthouse. Now is that we need to get the range from the Pushu lighthouse to the fixed position. So it says that it got in the 330 relative or 170 degrees from Pushu lighthouse, the distance is about 6 nautical miles. So we got here 11 degrees and 45 minutes, 1, 2, 3, 4, 5, and 6. So that will be our distance from the Pushu lighthouse, 6 nautical miles. Pushu lighthouse is over here, and then make a circle of position, this one. The next is we need to locate our ship's bearing. The ship's bearing is about 200 degrees true. So 200 degrees true is right here, this one. Then drag your triangle ruler to get the fixed position right here, this one. And that one. Then make a line of position, this one. Then we have here a fixed position. But don't forget to write this line of position or the ship's bearing of about 220 degrees through of about 10 knots. And now we have here a fixed position again right here, so we'll name it as fixed position 1300. So that will be the fixed one. But since you're asked to get the distance after a half of an hour, so we have here a 10 knots. A half of 10 knots because it says in 1330 to 1400 hours, so we got 10 knots. In order for us to get the 10 knots, we need to use the longitudinal scaling. Then 1, 2, 3, 4, 5. Why 5? Because half of 10 knots is 5. That's why we got 5 knots. Then 5 knots. So this one. So we got 5 knots. So this will be a 5 nautical mile right here. So we'll name it as the dead reckoning. Dead reckoning. This is a common notation, dead reckoning. This one, then we'll name it as DR 1400s. So that one. And then we're going to plot also the falling tide. It says here that it has a falling tide with a tidal stream of about speed of 0.6 knots. So tidal stream in Tagalog is yung, in vernacular speaking, a tidal stream is yung sulog or current of the water. So this one, as you have seen right here, that is the symbol. Then drag your triangle ruler to the point where your 1400 is located. That one. This one. Then put an arrow. So it says of about 0.6 knot. So 0.6 knot right here in our longitudinal scaling. 11 degrees and 45, 11 degrees and 46, 11 degrees and 47, and blah 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 and so on. So it means that this interval or this lines is about 2. So 11 degrees and 45, 2, 4, 6, 8, and 11 degrees and 46. So we are asked to get the half of 0.6 knot. So half of 0.6 is 0.3. So this will be the 0.3. So it between this one, 0.1 and 0.2 is equals to 0.3. So this will be the distance. Now locate this part. This one we have here. So this will be our estimated position of 1400, so 14 hours. So again, this will be the 330 relative bearing or 170 degrees through. This one. This will be the ship's course or ship's bearing of about 200 degrees through, above, with a 10 knots speed. Then we got the fixed position, 1300s. This one. And then we got a dead reckoning of after half of 10 knots is 5 knots. That's why we got here dead reckoning. Then and the external forces like the current, that's why we got an estimated position at 400 hours. And lastly, we need to determine the latitude and longitude of the ship's fixed position at 1330. So the 1330 is right here, this one. So we need to locate the longitude and latitude of that one. 11 degrees and 50.6. And now will be the latitude. So we have here, drag our ruler down. So 121, decrease, and 9 minutes point 6. That will be our latitude. So that's all for this video, and thank you for watching.